Welcome back to You Revise, where we talk about everything exams. Take a look at question 9 from the 2017 exam. It reads, an example of an undesirable electrochemical process is the corrosion of metals. Which one of the following equations does not represent what might occur during corrosion? We're given a list of equations here. We're going to go through them to see which one does not represent what might occur. But before we do that, let's take a look at the syllabus point here, which says corrosion of iron is an electrochemical process. So it's electrochemical, which means it must involve redox reactions that can be prevented by a range of techniques, including by the exchange of oxygen and or water through cathodic protection, right, and sacrificial anode. So this is, yeah, that's pretty much the point. We're not interested in the prevention, but we just need, for this question, you just needed to know the first part of this statement. Now, let's take a look at what the examiner had to say. The examiner says 35% of candidates got this question right, which is a very low percentage as well. This is what the examiner had to say based on their analysis or evaluation, whatever we want to call it. This question referred to the corrosion of metals as an example of an electrochemical process, which is exactly what this syllabus says. Knowledge of corrosion reactions was not required to correctly answer this question. There was only one choice of equation that was not a redox reaction. So there was only one choice here that was not a redox reaction, because I said it says corrosion of iron is an electrochemical process. So yes, it's an electrochemical process. It means it must involve redox reaction. So if there's a process that doesn't involve undergo redox, that is the process we are looking for. While 35.2% of candidates answered it correctly, 34.4% of the candidates chose the alternative, which is D. Right. The lead equation containing lead, indicating the likelihood that they held a common misconception that only iron corrodes. Yeah, I find that most students think that it's only iron that corrodes. Corrosion, it's just like the oxidation of a metal, basically. The next most common response chosen by 20% of the candidates did not contain any metal or metal ion, which means another misconception again to think that only corrosion equations involve metals. I mean, all corrosion processes involve metals only, but this is actually, B is actually a crucial step in the process of wet corrosion. Now, let's look at these answers. Right, we've got the first one, which is showing that iron 2 hydroxide is interacting with water and oxygen to form iron 3 hydroxide solid. As we can see, the oxidation state of iron has gone from 2+ to 3+, and that of oxygen has gone from 0 to -2 here in the hydroxide. You can calculate those, apply the rules. This has undergone oxidation, but generally this is towards one of those steps crucial in oxidation of a metal or iron, whereby iron is now converted to iron 3. When this iron 3 dehydrates, it forms a complex compound Fe2O3, which is hydrated with water like this. This is going towards the final step of this process. So yes, this equation occurs during the oxidation of a metal. B, oxygen forming hydroxide ions. Obviously, yes, this is the part of the hydroxide ions that end up bonding with the iron hydroxide. So yes, this process occurs during corrosion of a metal. Let's look at the next one, which says iron chloride solid going to this aqueous. So this is just a dissolution process. It doesn't have anything to do with corrosion. We just took iron chloride, dissolved it in water to turn into ions, and there is no change in oxidation state. So this one does not occur in the process of corrosion. Lead 2 plus to lead 4 plus. Yes, this is a possibility. Let's say I've got, let's say, my fence or a piece of metal that's sitting in my garden, and for some reason we've got a piece of lead sitting on there, and since lead is more reactive than this metal here, this is lead, this is a less reactive metal. I'm just giving you something hypothetical. The one that's going to corrode in this case is lead. Why? Because it's going to donate its electrons and they'll go on this metal, and when they get here, lead becomes Pb2 plus. Because Pb2 plus is not as stable as the lead 4 plus, it transitions further, oxidizes further to lead 4 plus, which is one of the most stable oxidation states of lead ions. Okay, so yeah, this one can occur during corrosion of a metal. So that leaves us with C as our correct answer on this one. I shall see you when you attempt the next. Thank you once again for watching. I shall see you in the next video. I hope this video was very helpful, and I would love to hear any questions, any concerns, or anything that you think could have been done differently in this video.